आज आमादेर जेटा टपिक सेटा होच्छे एडिशन নিউক্লিওফিলিক एडिशन nucleophilic addition to carbonyl carbon oxygen double bond. Nucleophilic addition to carbonyl carbon oxygen double bond. We know as per terms, addition reaction is such a reaction where one molecule is completely added to another molecule. That is, if there is a double bond, the total H annual molecule will be added to this one and the structure will be like this. Or the reverse, the Nu in this position and the H is in this position. When we are talking about nucleophilic addition to carbon oxygen double bond in carbonyl compounds, then আমাদের কয়েকটা জিনিস মাথায় রাখতে হবে as per the general property of carbonyl compounds. We already have studied that when this is the basic structure, as oxygen is strongly electronegative atom, carbon has its own electrophilicity and it is electron deficient. Thus, when addition reaction occurs to carbonyl carbon oxygen double bond, the addition reaction must be nucleophilic addition reaction. That is, one nucleophile will attack to this electrophilic center, that is carbonyl carbon, and the product will be generated following the reaction steps. So at first we will see the general reaction mechanism. For general reaction mechanism will be like this, that carbon double bond O nucleophile will attack either from down the plane or from above the plane, and thus the pi bond will be shifted onto the oxygen atom and the transition state will be like this. And the compound at first will be like this. This O minus will take the H plus as a conjugate part of the nucleophile from the solvent and form this type of molecule. This is the general reaction mechanism, and if this reaction is going to happen, what will be the factors influencing this type of reaction? কি কি ফ্যাক্টর থাকতে পারে যারা এই রিঅ্যাকশনটাকে ইনফ্লুয়েন্স করতে পারে? তাহলে ফ্যাক্টরসগুলোর সঙ্গে রিঅ্যাকশনটাকে স্টাডি করতে যাতে আমাদের সুবিধা হয় সেই জন্য আমরা কি করব, রিঅ্যাকশনটাকে শর্টলি ডান দিকে হচ্ছে কি আমরা ড্র করে রাখবো. ইটস লাইক দিস. এবার একে একে আসি যে ফ্যাক্টরসগুলো এই রিয়াকশনটাকে ইনফ্লুয়েন্স করতে পারে। 1 নাম্বার, কনসেন্ট্রেশন। If the concentration of the carbonyl compound, that means the substrate or the nucleophile or the both increases, then the rate of the reaction also increases. Secondly, electrophilicity of the carbonyl carbon. আমরা যেহেতু রিয়াকশনটাতে দেখতেই পাচ্ছি যে নিউক্লিওফাইলটা ইলেকট্রোফিলিক সেন্টারটাতে অ্যাটাক করছে এবং প্রোডাক্টটা দিচ্ছে, সো কার্বনের ইলেকট্রোফিলিসিটি যত হাই হবে তত হচ্ছে গিয়ে রিয়াকশনের রেট বৃদ্ধি পাবে। দ্য ইলেকট্রোফিলিসিটি অফ কার্বন varies as or proportional to the rate of the reaction. Rate of the reaction. So simple যদি আমরা চিন্তা করে থাকি যে electrophilicity of the carbon, how it will change or how it will vary. First of all, the substituents bonded to the carbonyl carbon, if they are electronegative in nature or minus I affecting group or minus R affecting group, they are attached with the electrophilic carbon of the carbonyl compound, then the electrophilicity of the carbon will be higher, thus increasing the rate of the reaction. Or in another way, if we assume the reaction to be catalyzed in acid medium, catalyzed in acid medium, then what happens actually? As we know, let's say Ha is the acid. As we all know that oxygen by the means of its lone pair always will try to intake the proton from the acid, then first it will become like this, which will be first it will become like this, which will be in resonance form like this, that is increasing the electrophilicity of the carbon. Thus in acid medium they perform the reaction in an increased rate. So rate of the reaction increases in such conditions. From these 3 points we have measured that the factors as concentration, electrophilicity of the carbon, and if the reaction is catalyzed in acid medium. Now fourth one is the steric factor. If there is large group attached to this carbonyl carbon, when the nucleophile will attack this one, in the attacking situation there will be not that much repulsion acting, but when it will become like this one, that is in the product form, then the nucleophile will feel more steric crowding. Thus larger group attached to the carbonyl carbon will decrease the rate of the reaction, as it will decrease the ease of product formation by means of steric crowding in the product structure. So here we can easily conclude that larger group in the carbonyl carbon will decrease the rate of the reaction. Next, number 5 is when the groups attached with the carbonyl carbon in alpha position, if there is any strong dipolar interaction, that is, say Cl Cl, that is, this Cl will, as it is electronegative in nature also, so this Cl will draw the attention of the electron density towards itself. Thus there will be a delta negative in Cl, delta positive here. Now again for oxygen, this will also will form this type of interaction. Now this delta plus and this delta plus, they will produce an extraordinary dipole-dipole interaction, that is, both are the positive in nature. And in this situation যদি এরকম ক্ষেত্র হয়ে থাকে, তাহলে যদি একটা নিউক্লিওফাইল এই মুহূর্তে এইখানে অ্যাটাক করতে পারে, this nucleophile will release this much repulsion, or this will relieve the substrate in this condition. যদি একটা নিউক্লিওফাইল এখানে অ্যাটাক করতে পারে, তখন কি হবে, কার্বন will be like this, and এই যে ইন্টারাকশনটা ছিল, সেই ইন্টারাকশনটা হচ্ছে গিয়ে খানিকটা হলেও তখন এই ডাইপোল ডাইপোল ইন্টারাকশনটা খানিকটা হলেও তখন মিনিমাইজ হবে কার দ্বারা, নিউক্লিওফাইল দ্বারা, বিকজ ইট হ্যাজ হাই চার্জ ডেন্সিটি, হাই ইলেকট্রন চার্জ ডেন্সিটি, অ্যান্ড দেন ইট উইল ইন্টারাক্ট উইথ বোথ দ্য ডাইপোল, thus minimizing the dipole-dipole interaction of the carbon and the immediate group attached with it. That is why they will facilitate the reaction, or the rate of the reaction will increase. Thus strong dipole-dipole interaction in alpha position will increase the rate of the reaction, and these are all facts which will influence the total rate of the ADN2 reaction, which we call AD for additional, N for nucleophile, and 2 for bimolecular reaction. Because in this reaction the substrate and nucleophile both are involved in the rate determining step in this type of reaction, that is why it is bimolecular reaction. It is additional reaction by its nature, and the additional reaction is nucleophilic in type, because the nucleophile acts here as the reagent and the acting attacking agent. That is why it is ADN2, or additional nucleophilic bimolecular reaction. So from all these studies we can easily conclude that the general reaction may be in two ways. Either it is in acid catalyzed step, or it is not catalyzed step. So general reaction will be like in two ways. Number one, non-catalyzed. When it is non-catalyzed, then the reaction mechanism will follow the simple as we stated earlier, nucleophile will attack here, the pi bond will be shifted onto the oxygen atom, and this the H plus from the conjugate part of the nucleophile or the solvent, this will take so first step, let us say this, and then this will take one H plus from the solvent, and here it will produce the compound like this. If there is no H plus, there is any E plus, then the minus will take the H plus or E plus and producing this type of compound, or O minus E plus. This is what happens when it is in non-catalyzed state, and if it is catalyzed, then acid catalyzed, then the reaction will be like first it will take here from acid, thus freeing the it will be in resonance with this one, producing this type of carbocation. Now nucleophile will attack to this carbon, thus the step will be like this. And from this one, here we have released one A minus from the conjugate part of the HA acid. This A minus will now take the proton from the conjugate proton of the nucleophile and thus releasing this to nucleophile, and finally the product will be like this. So here is the reaction mechanism for acid catalyzed nucleophilic addition to carbonyl carbon double bond. Now let us see some examples of addition reaction. First of all, we see addition of cyanide. Addition of cyanides. What happens when we add cyanides to carbonyl carbon? Now, if we put HCN, then the reaction will be like directly Cn minus to this one and it will be like this. If we put NaCN in presence of H2O, then that is not acidic in turn. So first the Cn minus will attack, which is liberated from NaCN, will attack from this, and this will be the intermediate product. First the salt, then this will take proton from water molecule and it will form OH plus NaOH. So there is two types of cyanide addition. Now after we get the cyanides, what else we can produce from this cyanohydrin? This is called actually cyanohydrin. Now when once the cyanohydrin is produced, what else the products we can obtain from these cyanohydrins is like, let us say we get this cyanohydrin. Now from this we can easily process various of products. Like if we hydrolyze this cyanohydrin, then this cyanide group will be oxidized to acid, thus producing hydroxy acids. Now if we add H2Ni or LiAlH4, then it will be converted into CH2, NH2 and OH, that is hydroxylamine. And even from this one again we add some water soothing agents like concentrated H2SO4, 95% concentrated H2SO4 or P2O5 or Al2O3 and heat. Let us say 95% concentrated H2SO4 or P2O5 or Al2O3 and heat. What will happen? One water molecule will be exited from this compound and thus producing an alpha beta unsaturated carboxylic acid, that is C double bond whatever it is and this one and COOH, alpha beta. So we can easily see that after addition of cyanides from the cyanohydrin we can obtain these type of products easily. Even if there is a cyclic ketone, say this, when we add dry HCN or directly HCN, we will have this type of cyclic cyanohydrin, and from this one again by hydrolyzing and by hydrogenating we can obtain this type of compound. Or simple. Let us take an example for addition of amines. addition of amines. How it will work? As simple as the previous one. NH3, it will attack here by its lone pair, and now NH3 plus, let us draw as NH2 and H, and it will be like O minus. This O minus will take this proton and produce the product as hydroxyl amine. As simple as that. Now even if we try to replace this amine group with help of another nucleophiles, then it will show some basic nucleophilic substitution reaction and substitute this amine group with the incoming nucleophile. Say any nucleophile, it will attack this carbon, and now the product will be like C, Nu, OH, and this. So this was one type of addition of amines. Now we see a very generated topic, acetylides. 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 What is acetylides? Now when it is treated with NaNH2, H2O, as NH2 minus is a strong base, it will take a proton from this area or this surface and produce an anion called vinolates. Vinolates. This is metallic vinolates. Why metallic? Because Na plus is metallic in character. And why they are called vinol? As we say, if we compare this structure with OH structure, then we say this as alkanol. Alkanol. So as it was an alkane group attached with this oxygen. Now if we compare this one with this, so when it produces as anion, then we call alkanoates. Alkanols. Now when we compare this with this structure, then as it is alkyne, that is why they are called vinolates. Alkyne, that is ALKYN, alkyne. So we remove the ALK part and we get YN-olates, that is vinolates. Now as we said, these metallic vinolates are very good nucleophile and they will readily attack to the carbonyl carbon. They will readily attack to the carbonyl carbon, and thus they will produce this type of compound. From this, what we can obtain actually? Rather, if we treat this one with Al2O3 and we generate heat, then as Al2O3 is a very very much water soothing compound, so one H2O molecule will be relieved from this compound and thus producing, let us say here is one CH3 group attached. Thus one water molecule will be released from this side and it will produce like CH2 double bond C triple bond CH. And if we treat this with PDH2 in presence of BaSO4 as poison of catalyst, then first of all it will be converted into C double bond CH double bond CH2, and then let us say here is one whatever it is one CH3 group attached to the carbonyl carbon. Now if again we treat this with Al2O3 and produce heat, then we will obtain the structure like water will be released from here and the structure will be like CH2 double bond C CH double bond CH2, that is here in and here double in. So this was the addition of acetylides. Now let us take an example of addition of Grignard reagents. Grignard reagents. As we all know, Grignard reagents are compounds of this type RMgX, that is magnesium alkyl halide. Now from this type and the special character of Grignard reagent is that it will produce an alkyl group like R- which is a great nucleophile. So this one will act as nucleophile. Now the process is so simple. The nucleophile will attack here, this will come to there, and now the compound will be first like this. After this one, if we hydrolyze, then we will get. So this is a very much good process of obtaining tertiary alcohol from any ketone compound by means of adding Grignard reagent. Now let us take example of adding alcohols to the carbonyl group. Before we proceed, here again we see what we can obtain from there. First we add RMgX, then hydrolyzed, and thus we get this. So here also we can obtain alkenes. How? If we substitute these groups as, suppose this one, and now we add 95% H2SO4, then it will release one water molecule and produce CH2 double bond C R CH3. If we add nucleophile from here, any nucleophile, then it will attack from this side and release the, this will not attack from this side, because as it is a tertiary carbon compound, then adding nucleophile will highly facilitate SN1 reaction, that is substitution nucleophilic unimolecular reaction, and will produce CH3, CH3, R, NU. So also by means of Grignard, adding Grignard reagent, we can obtain this type of products after we get the alcohol from the carbonyl compounds. Now let us say addition of alcohols to the carbonyl compound of alcohols. What will happen then? There will be hemiacetals and acetals from the addition of alcohols. How does it work actually? Let us take an example of any carbonyl compound, and now we add NaOET in ETOH. First of all, in this case, they will attack as ETOH by means of this lone pair will attack here, and then it will be like this. Thus, first it will produce O minus ETOH here. ETOH will be in this type of stage, and the OET minus obtained from NaOET will take this proton, releasing this bond electron onto the oxygen, and it will produce this one. Oh, sorry, there is another kind of. This O minus will intake this proton, and it will be OH, it will be OET. Now this is called hemiacetal. After this stage, again with the help of NaOET dissociating as OET minus and Na plus, that OET minus will attack this carbon and act as nucleophile, thus releasing the OH. Then there will be the compound OET and OET. It is acetal. Previously, if it was from an aldehyde, then we used to call it hemiacetal and acetal, and if it is from ketone compound, then we used to say it as hemiacetal and ketal. But nowadays this name has been changed and both are said as hemiacetal and acetal, but for ketone they are called acetal from ketones. Now this is the process of addition of alcohol. This OET group further can be removed or substituted by means of substitution reaction. So it is very obvious that they are good reagent for having substitution reaction, the acetals and the hemiacetals. And what is more importance of acetals or hemiacetals? There is a very much importance of acetals for cyclic acetal. Say if we add diol, then firstly what will happen, this OH will attack here and thus the reaction will proceed like this. Or let us draw this in more convenient way, this. H plus from solvent, or if it is acid catalyzed, then it will produce OH, O. Now this OH by its lone pair acts as nucleophile and attack here, will release this OH minus and producing this acetal. It is cyclic acetal, and this acetal is used as a blocking agent. Blocking agent means it is not that much, it is resistant towards oxidation. অক্সিডেশনের দিক থেকে এটা হচ্ছে গিয়ে এতটা রেসপন্সিভ না হওয়ার জন্য যে সমস্ত কম্পাউন্ডের ক্ষেত্রে সিলেক্টিভ অক্সিডেশন ঘটানোর ব্যাপার হয়ে থাকে, সেই সমস্ত ক্ষেত্রে একটা গ্রুপকে, তার কিটোন গ্রুপটাকে প্রিজার্ভ করে বাকি অন্য জায়গাতে হচ্ছে গিয়ে অক্সিডেশন ঘটানোর জন্য হ্যাঁ এই অ্যাসিটাল ফর্মেশনের মাধ্যমে কিটোন গ্রুপটাকে প্রিজার্ভ করা হয়। And after this what can we do? Just hydrolyze this, it will produce again OH and OH, and now on 95% H2SO4 treatment we can get again the ketone back or the carbonyl compound back. So if there is any group, like for example let us say there is one this type of compound. Now if we add this, first it will produce the compound as acetal and here will rest part. Now from this one, if we reduce this part from acid, if we reduce this part, what will happen? Or let us say from this acid we convert it into COCl, then we convert it into CONH2, and then with the help of H2PD or H2NI we convert it from this one as CH2 and NH2. throughout the process, if this part was not blocked by this one, যদি আমি এই গ্রুপটাকে এইভাবে ব্লক না করতাম তাহলে at this stage and at this step or before this one, এই কার্বনিল কার্বনটাও কিন্তু রিয়াকশানে অংশগ্রহণ করতে পারত, কিন্তু যেহেতু এটাকে আমি এইভাবে অ্যাসিটালে কনভার্ট করে ব্লক করে দিয়েছি, তাহলে শুধুমাত্র সিলেক্টিভ ওয়েতে আমি এই গ্রুপটাকে নিয়েই এখন সমস্ত বিক্রিয়াগুলোকে ঘটাতে সক্ষম হয়েছি। এবার এই পজিশনে আসার পর যখন আমি এটাকে এগেন বাই হাইড্রোলাইসিস অ্যান্ড 95% H2SO4 treatment, we can again get back to the carbonyl carbon as gas. So from this we can get this by the whole procedure only by blocking this carbonyl group. এইভাবেই হচ্ছে গিয়ে কার্বনিল গ্রুপটাকে প্রোটেক্ট করে সিলেক্টিভ কোনো একটা পার্টের অক্সিডেশন ঘটানোর জন্য, সিলেক্টিভ কোনো একটা পার্টের বিক্রিয়া ঘটানোর জন্য বা অক্সিডেশন ঘটানোর জন্য বা রিডাকশন ঘটানোর জন্য আমরা অ্যালকোহল অ্যাড করে তাকে অ্যাসিটাল ফর্মেশনের মাধ্যমে ওই কার্বনিল গ্রুপটাকে প্রোটেক্ট করা হয়। দিস ইজ দ্য মেন ইম্পর্টেন্স অফ অ্যাডিশন অফ অ্যালকোহলস টু দ্য কার্বনিল গ্রুপস। এরপরে আমরা মোটামুটি হচ্ছে গিয়ে বিভিন্ন টাইপের অ্যাডিশন রিয়াকশানগুলো দেখে রাখলাম যেগুলো কিনা কার্বনিল কার্বন গ্রুপে ডাইরেক্টলি অ্যাড করা যায়। এখন এই অ্যাডিশন রিয়াকশানের মাধ্যমে এর কী কী অ্যাপ্লিকেশান হতে পারে বা স্পেশাল কী কী টাইপের আরও রিয়াকশান ঘটতে পারে সেগুলো আমরা এর পরের পার্টে আলোচনা করব। যে ভেরিয়াস টাইপস অফ রিয়াকশান অকার্স থ্রু দিস টাইপ অফ নিউক্লিওফিলিক অ্যাডিশন টু দ্য carbonyl carbon oxygen double bond. Till then, thank you.